Well, hello, epidemiology students. This is your Professor Dr. Raywat Deonandan, fresh from a bout of unspecified virus, which I will not discuss with you on this public forum, but if you want to know what I had, I'm probably going to tell you in exquisitely horrible detail. But because you missed the Friday class, or rather I missed the Friday class, the things that we would have covered on that class will not appear on the final exam. So today I am preparing this video to explain to you what the final exam will look like instead. So consider this to be the last class of the course. And usually I like to end the last class on a philosophical note, and I'm kind of upset that I was not able to do that for you. So maybe I'll find a moment to mention some of my observations in this little recording. Okay, like I said, we're going to review the year, we're going to talk about the final exam, and maybe, if I'm in the mood, I'll have some final words. Because as I'm recording this, it is Sunday morning at 3 a.m., and I think I want to go to bed. So, what we've talked about this year, we've learned about biases, which in my opinion are the heart of epidemiology. If you understand bias, you understand the logic of science, you understand the basis of population health sciences, and you're a better person for it. We talked a little bit about evidence-based medicine, and to understand evidence-based medicine, you have to understand the hierarchy of evidence. And we seem to think that the best kind of evidence comes from systematic reviews of good quality studies. We spent a lot of time talking about the types of studies, and I showed you that flow chart that I'm quite proud of that separates qualitative from quantitative studies and divides up quantitative by observational and experimental studies. And amongst the observational studies we have our cohort case control and cross-sectional studies, but there are a host of other ones as well that we touched upon. In this list here we have nested as well. I don't really need you to know what a nested study is, be aware that it exists, but these other ones I think you should spend some time reviewing. We learned a little bit about databases, not a lot. We just touched upon it a bit, because if you're going to be an epidemiologist, you're going to have to work with databases to some extent. Now, the heart and soul of classical population epidemiology is in measurements of morbidity and mortality. So morbidity classically are incidence and prevalence. There are two kinds of incidence, and dailies. Remember the disability adjusted life years? Mortality, we spend a lot of time looking at the various types of mortality. The CFR and the PMR and the crude rates. We also looked at standardization, both the direct and indirect methods. We touched upon survival analysis, and that one aspect of survival analysis that gives me nightmares, the Kaplan-Meier method. Even though it's easy, for some reason I can't get it through my head. So see, I got issues as well. Now, in the second half of the class, we looked at screening tests, and I wish I could spend more time on screening tests because they're pretty important. And we can go deep into the math. We didn't have a whole lot of time to go into it, but we did touch upon a variety of aspects of screening tests. In particular, sensitivity, specificity, false positives, false negatives, the LR positive, LR minus, the PPV, and the NPV. We also looked at agreement, in particular, Cohen's kappa. We didn't look at Fleiss's kappa, but I want you to know what it was, and be aware that there are different other kinds of interclass correlations that are measurements of agreement. We looked a little bit at validity and reliability, both for tests and for studies. We looked at the natural history of disease and why what we know about is actually the tip of the iceberg. We only know about things when they enter the healthcare system. So the overwhelming majority of health conditions in the world amongst human beings we have no idea about. We looked at how to ascertain causality using the Bradford-Hill criteria. We looked at attack rate, which is a different kind of incidence rate. We also had these measurements of association, relative risks, odds ratios, attributable risk. And remember, there are two kinds of attributable risk, population and attributable risk in the exposed group. So get those straight in your head. We looked at how to interpret p-values. We did not look at confidence intervals. I didn't have time this semester. It's amazing how less time I had this year than in previous years, and there are several things I did not cover this semester that previous years have covered, and I feel really badly about that. I'm sure you don't feel badly because it means you get less to study for your exam, but your education is not complete, so I apologize. We also looked at randomization, in particular two types, block versus simple randomization. We did not cover these things. These are other things that we've covered in previous years that for some reason there was not enough time. Well, I know exactly what those reasons were. We missed two classes, the last class and the class I canceled for the poster project. So, we didn't cover math studies, and there's a whole host of choice questions I could have asked you on the exam about that. We didn't review chi-square, which is something you had in second year stats. There's something called decision analysis, where we add sort of weights to certain outcomes of interventions and allow the math to guide us through clinical decision making. I think you'd find it quite interesting, and I feel bad that we didn't get a chance to look at it. We didn't do sample size calculation as we did in second year stats, so that would be a review. And I want you to be aware that there are these other kinds of epidemiology out there. There's molecular epidemiology, epidemiology that happens at the molecular level. Epigenetics, that's where your environmental circumstances determine whether or not certain genetic traits will be expressed or not. We didn't cover these things. So, having talked about the things that will not be on the exam, let's talk about the exam now. It's going to be not a Sunday. It's not a Sunday, is that? That's going to be a Thursday, I believe. So let's take that away. No Sunday. No. Ma. It's going to be December 22nd in Denmark, 1160 from, that should be 2 to 5 p.m. Bad, Ray. Bad. I'll fix this before I upload the slides. Bad. As usual, bring a calculator. Bring the ever-loving legendary cheat sheet. And I accept all currencies for bribes except rupees. Rupees are not doing well right now, and so no rupees. Thanks. I'm kidding. It's a joke. In case people are listening to this and professors want bribe. No, I don't want a bribe. I'm kidding. Jeez, people can't take a joke anymore. All right, the exam is cumulative. Why? Because it's fourth year. Suck it up. That's what adults do. Okay, it's cumulative. We're going to test you on everything you learned this year. There are 95 questions. Sounds like a lot, but remember the midterm was half that length, was it? I don't remember. 56. What? That's not true. That's not true. I can't believe I got all these errors here, so take that away. It's actually 29 calculations and therefore 61 theory questions. Okay? This is the wrong distribution. We do have one bonus question. Last year we had 90 questions, but there's more content to cover. Year before that, there's 100 questions, so don't complain. 95 is a good medium. The exam, again, is worth 40% of your final mark, I believe. That's right, right? I think so. I'll have a check on that. I think that's right. We're only looking at the things covered in the lectures. If it's in the textbook but not in the lectures, don't worry about it. Think about the textbook as a source to clarify the things that we mentioned in class. You can use a textbook for practice. I will upload more practice questions, and you can come see me in my office hours. I have physical office hours on Tuesday coming up, and virtual office hours that I posted on the website, and possibly more physical office hours to come. Remember, I will not answer any questions 24 hours before the actual exam. That's to cut down on people going crazy the day before and making me crazy with your craziness. So let's minimize crazy, shall we? Crazy bad. Right. A funny thing happens every year. At the last second, people start doing two things. One is they start thinking about using the midterm exam as a study tool. That's fine. You can do that. Except, I am not a study tool, because you need me to see the midterm exam. And the reason you need me for that is that the midterm exams are no lock and key because we reuse some questions year to year. So, well, I am a tool, but not a study tool. So, there's that. The other thing that happens is some people do the math and realize, oh, I need this number of marks to get an A in the class, and I haven't got this many. But if I seem to engineer more marks out of the midterm, it takes me one step closer. So suddenly a lot of scrounging happens. No, it's too late for that. The midterm mark will not change. If you want to see your midterm, there is one last chance. That is during my physical office hours on Tuesday, December 6th. And your midterm mark will not change. So if you want to see the midterm questionnaire, you do so just for your own edification. The actual answers to the midterm, and your answers are already posted in an Excel file on the website. Right. The exam is all multiple choice. And again, you can bring a cheat sheet with whatever you want on it, writing on both sides, typing, writing, graphics, I don't care, right? Just one 8.5 by 11-inch paper. Yeah. So, there will be no Kaplan-Meier calculations because I hate it so much. There's going to be a lot of theory, a lot of questions you can figure out without having to do any math. Obviously, 61 such questions. We're going to stress the pluses and minuses of study design, so understand why certain designs are the way they are. There's a fair amount on biases, there's a fair amount in computing odds ratios and relative risks, but there's a lot on screening test stuff, so get that straight in your head, how to use or compute the aspects of screening tests. As I mentioned, why can't I do math? I can't do math because clearly it's 3 a.m. That's wrong as well. It's 29 computation questions and 66, that's right. Oh, Ray, I need to go to bed. 66 is correct. 66 and 29 is the distribution of the question types. And you'll have 3 hours to complete it. Okay, sample questions. I'll just zip through these fast. You can see these for yourself. Right, there you go. Yeah, it's there, right? All this stuff is going to be on the website, so you can look at it later on, after I fix my errors. So, what did you learn this year that was useful for your everyday life? Well, you learned about bias. And the reason that's useful is when you hear about things in your everyday life, even if you don't end up being a scientist, you will be more critical. You're going to be a smarter person, a better engaged individual, a better citizen. You learn a lot about study designs. Why is that important? Because you now understand the limits of scientific knowledge. Right? How do we know certain things? How do you know smoking causes cancer? It's not because someone did a randomized controlled trial. It's for other reasons. You learn a lot about causation. So what do we mean when we say smoking causes cancer? How do we make that determination? Are we 100% sure? You learned about how to tell if an article is good or bad. Now you get that in other classes as well, but epidemiology reinforces that. You learn about the nature of knowledge. How do we know what we know? And is what we know rational? And you learn about data. So a lot of questions still linger, and a lot of it has to do with not having enough data, or the data is wrong, or the data is misclassified, or it's not what it purports to be. You learned about logic. Remember, from your poster presentations, you remember that your methods can only answer the questions that you ask. So you have to ask the right questions. Now, we did not learn about decision making, right? I wanted to teach you about that, but we didn't do that. But we did learn about evidence, right? So, are you shocked to know that the world is not evidence-based? I think you're cynical enough to have made that conclusion yourself. The world is opinion-based, and we scientists rush to catch up, to say, hey, but I have facts, I have evidence over here, and nobody cares. We didn't do decision-making, so sorry about that. The future of epidemiology is multifold. There's so much going on. You have no idea. As I mentioned, molecular and genetic epidemiology are big. There's a lot of overlap with other sciences like sociology, psychology, and political science, etc. A big growth area is around information technology, with big data coming down the pipeline. Business applications are now manifesting. So it's a good place to invest your career. Like I said, I don't know of any unemployed epidemiologists, unless they're unemployed for a reason, i.e. either crazy or taking time off. So, one last thing I want to talk about is that epidemiology is a paradigm. Remember paradigms? We talked about paradigms in the first class. A paradigm is a way that we know things. Okay? It doesn't necessarily mean it's the truth. It's a paradigm that really forms the foundation for what we think about as Western science. It's experimental, it's observational, it's supposedly objective. It exists within the positivist paradigm space, which tells us that maybe objective reality actually exists. Right? But that might not be the case, because everything is value-laden. It's hard to think about something that we consider to be a fact that is not in some way filtered through human values. So let me give you this example that I think I might have given to you already. I don't recall, because it is 3 a.m. and I'm tired. The example is this. If I were to ask you where the seat of consciousness is, someone among the class will say to themselves, oh, the brain. The brain is where my consciousness resides. And that's a perfectly rational, scientific, modern answer. And then I ask you, how would you test that assertion? Can you devise for me an experiment, a study, that would conclude with, therefore, the brain is the seat of consciousness? Now, after some arguing, I like to think that some of you would come up with the idea that if you took a big hammer and hit me on the head and damaged my brain, you would either impair my consciousness or destroy my consciousness. Okay, that's great. So you've shown there's a linkage between me having a brain and having consciousness. But put that aside for a second and consider another possibility. Consider a paradigm in which the brain is not the seat of consciousness, but is a transceiver or transmitter for receiving and broadcasting consciousness that exists all around us. I'm not saying that's the case, okay? Don't run home to your parents and say, the professor said consciousness is everywhere. He's being all freaky, Deepak Chopra. No, that's not what I'm saying. I'm saying consider the possibility for a second. If you consider that possibility, now apply that same experiment. Take the hammer, hit me over the head, damage the brain, damage the transceiver. What happens then? There's an impaired signal. There's impaired consciousness. If you destroy the brain, you destroy the transceiver. You cannot get the signal anymore. So what we've done there is show that the same set of experiments confirm both paradigms. Taking the hammer to the brain confirms both the original paradigm, that the brain is the seat of consciousness, and it confirms the competing paradigm, that the brain is a transceiver for receiving consciousness. Right? And the lesson there is the evidence does not point one way or the other. It's our values that cause us to conclude that the first paradigm is correct. Obviously, there's other evidence in the world that suggests to us that the brain is a seat of consciousness. Okay, don't go down that path. My point is that our tools are limited, and very often we take the extraordinary leap to conclude that because we've observed some things, these other assumptions I've made are correct. I bring this up because after studying epidemiology, what a lot of young people then do is develop a sense of arrogance about unusual or fringe or frontier science. And I'd like us to remain humble if we can, to consider that we don't know everything and that knowledge is still emerging. Okay, that is all. So I will see you on December 22nd if I don't see you in my office hours. And I apologize for the errors in this slide. I will fix them before I upload. Bye-bye.